Hello and welcome to 3.5 Notes. Today we're going to go over the equation of a line in slope-intercept form. So hey, let's start with the important formula here. Y equals mx plus b. Okay, write that down. Y equals mx plus b is the equation of a line in slope-intercept form. Okay, and remember, you can pause this presentation, fast forward, rewind. You're in total control of this situation, so you can watch this presentation at your own pace. Okay, but this is the main thing. Y equals mx plus b, the equation of a line in slope-intercept form, where again m is the slope. We went over slope in 3.4 notes, where m is the slope and b is the y-intercept, or b is where it crosses the y-axis. So if you have x and y coordinate plane, and the blue line is the line that we're talking about, then B would be that red point right there, that red dot. It's where the line crosses the y-axis. Okay, B is the y-intercept. Okay, so you should write this down as well. Of course, anything that I write down, you should write down as well. And so the equation of a line in slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And the y and the x are never filled in terms of writing the equation of a line. In other words, the final form for writing an equation of a line would look something like this: y equals 2x minus 4. Excuse me. That means the slope of the line is 2 and it crosses the y-axis at negative 4. Or you might have something like y equals negative 3/4 x plus 6. That means the slope is negative 3/4 and the y-intercept is 6. It crosses the y-axis at 6 and it has a slope of negative 3/4. So you would start at 0, 6, for instance, like maybe you would be, say, up here, 0, 6, and you would go down 3 and then to the right 4. 1, 2, 3, 4, and that's how you would get the line. Okay, something like that. And we'll go over that more in the future. That's not today's emphasis, but I just wanted to give you a little understanding of what the equation of a line would look like. The x and y does not get filled in because how many points are on a line? Right? How many points are on a line? There's an infinite number of points on a line, right? There's a million, billion, zillion, infinite number of points on a line. So what it's saying is, for this particular x, what does y have to be in order to be, say, on that line? So there's an infinite number of x and y's. You leave the final form of your answer like this, okay? Y equals 3/4 x plus 6, filling in only the m and the b, okay? That's important. To write an equation of a line, you need to know the m, or the slope, and the b, or the y-intercept. Okay? All right, moving right along. Using this graph, write an equation of the line in slope-intercept form. So please write down this entire prompt. We're going to continue on the next frame. So I've just copied this prompt down on this new frame. If you've copied it down already, of course, there's no need to recopy it. But we have these 2 points on this graph, and our task is to write an equation of the line in slope-intercept form. So here's how you go about doing it. I want to write an equation of the line in this form. This is again called slope-intercept form. And remember, all I need to find out is the m and the b, the slope and the y-intercept, and then you just leave it as y equals, the number for the m, x, plus, and then the number for the b. You leave it in the form with the x and y there in that final form, right? So we just have to find out what the m and the b are. And in 3.4 notes, we went over how to find the m, or the slope, right? The slope is equal to y2 minus y1 over x2 minus x1. So you take these values here and you put them into the formula. If you need any review on that, please refer to my 3.4 notes. Okay? So plugging in those values, you get 1 minus negative 1 over 3 minus 0, which reduces to 2/3. So my slope is 2/3. So far I have y equals 2/3 x plus b, but I don't know what my b is. I don't know what my b is, but I remember what it is, what the definition is. The b is my y-intercept. It's where it intercepts or crosses, right? That's what intercept means, to cross. It's like an interception in football. It's where the intended receiver's path is crossed by a member of the opposing team, right? It's an interception. So intercept means to cross over. So this crosses over the y-axis right here at 0, -1. So my b, or my y-intercept, is -1. So I know everything now. I know my slope and my y-intercept, and I can just plug it in. Y equals 2/3 x minus 1. That's the equation of a line. Again, you leave the x and y there because there's an infinite number of x and y's, and my y-intercept is -1, and my slope is 2/3. Okay? But now let's do the same exact problem, but let's pretend we don't have it graphed. And let's further pretend that we don't even know that the y-intercept is -1. How would we be able to figure that out if we didn't have it graphed? Okay, so how do we find the b, the y-intercept, if we don't have it graphed or if it's not given to us? And the way that's done is you borrow the use of a point. Okay, write that down. It's very important. You'll be using this technique quite a bit. You will borrow the use of a point. Okay, so I'm going to borrow the point 3, 1. So going back to the other frame, I'm going to borrow this point here, 3, 1. Okay. Okay, so you borrow the use of the point 3, 1 and you stick it into the equation y equals mx plus b. So in this case, 3 is my x, so I would plug it in there. Okay, right there. And the 1 is my y value, so I would plug it in there. And that's what I've done here. And so this is where you get the 1, right? That's my y is equal to m. M is 2/3, right? My slope is 2/3. And then x is this 3, which goes here for the x value. Okay? And look at that. Now I know I have everything except my b. I can now use it to solve for b. See, I just borrow the use of that point until I find my b. After I find my b, I don't need that point anymore. I'm just using it, exploiting it. Okay, so simplifying, 2/3 times 3 is 2. So 1 equals 2 plus b. And then subtracting 2 from both sides, you get b equals -1. So now, say I got my same y-intercept. Okay, so I'm just showing you how to find your y-intercept if it wasn't given to you or if you don't have the graph in front of you. So then you come up with the same exact equation. Y equals 2/3 x minus 1. Okay? So here we have a problem where we don't know what the b is. It's not given and it's not graphed. So we're definitely going to have to borrow the use of a point. Okay, so write this down. Write an equation of a line that passes through -2, 5 and 1, 2. Alright, so the first thing we need to find is the slope, and then plugging in values for the slope or into the slope equation, we get that, and then calculating it out, we get -3 over 1 plus 2. Remember, 1 minus -2 is the same as 1 plus 2, and so you have -3 over 3, which is -1. So the slope is -1. Okay? But we don't know the b, we don't know the y-intercept. So again, we have to borrow the use of a point. I'm going to borrow this point right here, 1, 2, and I'm going to stick it into the equation y equals mx plus b. Okay? And so then you get 2 is equal to -1 times 1 plus b. So this is the y. So it gets substituted for the y. That's how you get the 2. And then the m is the slope. That's right there. So that's where you get that from. And then the x is 1. So that's where you get that 1 in from. I plugged it in, substituted it in for x. And now we know everything except the b. I can use it to solve for b. Okay? So you get 2 is equal to -1 plus b. and then adding 1 to both sides, you get that your b, or your y-intercept, is 3. So therefore my answer is y equals negative x plus 3. That's the equation of a line that passes through these 2 points. Okay? So my slope is what? What would my slope be? My slope would be negative 1, and my y-intercept, or where it crosses the y-axis, is at 0, 3. Okay? And then the next problem is write an equation of the line that passes through 1, 5 and is parallel to the line y equals 3x minus 5. So working this out, what is the slope of the line that passes through 1, 5? What is the slope of the line that passes through 1, 5? Well, I don't have 2 points. I don't have it graphed. I can't use the counting method. But I know that it's parallel to this line. And remember what we learned in 3.4 notes, that parallel lines have the same slope. So the slope of the line that I want must be the same as the slope of this line. And the slope of this line is 3. So the slope of the line that I want must also be 3. Okay, so the slope is 3. And then, how do I find my b again? What is the b? What is the y-intercept? Again, I have to borrow the use of a point. So I'm going to borrow the only point that I know that goes through that line, which is 1, 5. Okay, so plugging that into y equals mx plus b, you get 5 is equal to 3 times 1 plus b. And if you'd like, you can pause this presentation and check to make sure that I've substituted the values in correctly. And then solving, you get 5 is equal to 3 plus b. Subtract 3 from both sides, and you get that my b, or my y-intercept, is 2. Therefore, y equals 3x plus 2. It has a slope of 3 and a y-intercept of 2. Okay? So these two lines, y equals 3x plus 2 and y equals 3x minus 5, have the same slope but different y-intercepts. That's what makes them parallel. So just to kind of give you a quick little picture of what that looks like, you have an xy coordinate plane. X is always horizontal, y is always vertical. We have this first line, y equals negative 3x plus 2. So if you notice, that has a slope of 3. So if you start at any point, you go up 1, 2, 3, and to the right 1, you get to your next point, up 3 over 1, up 3 over 1. You would always get to your next point, okay? Or you could even go, down 3, 1, 2, 3, and over 1, okay? Into the left 1. All right? And this crosses the y-axis at 0, 2. So I have it crossing the y-axis here at 0, 2. And this line is parallel to the line y equals 3x minus 5. If you notice, it has the same slope, right? You could start here, for example. You go up 1, 2, 3, and then to the right 1. And it passes through the y-axis at 0, negative 5, which is 1, 2, 3, 4, negative 5 down right there. Okay, so that's a picture of what's happening. You have two lines that are parallel, which means that they have the same slope, okay, thus making them parallel, but they can't be on top of each other, because if they were on top of each other, they wouldn't be parallel, they would just be the same line. So they have to have different y-intercepts. So if you have two parallel lines, they have to have the same slope, but they also have to have different y-intercepts. Okay, so that's the end of the presentation. And if you have any questions, actually I'm just kind of showing you here that there's what the y-intercepts are. Okay, so this y-intercept is plus 2, and this y-intercept is negative 5. Okay, again, you have to have different y-intercepts but the same slope for two parallel lines. So again, that's the end of the presentation. If you have any questions or concerns, as usual, please feel free to come ask me questions. Contact me at your convenience, and it would be my pleasure to help you. Okay? Bye-bye.